Hello, class 11th students. Today we will discuss the probability chapter number 16, exercise 16.2. The question number 1, what says? A die is rolled, let E be the event, die shows 4, and F be the event, die shows even number. R, E, F, and E and F are mutually exclusive. They are asking this question that E and F, these two events are mutually exclusive. So first of all, let's say what is the meaning of two events are mutually exclusive. We say two events are mutually exclusive. If we say events are taken, we take the E and F, these are the two events. These two events are mutually exclusive if E intersection F equal to 5. Means there is no element common in both the events E and F. So this question they are asking whether these events are mutually exclusive or not. If intersection of these events are phi, then we say it is mutually exclusive, otherwise not. So this is the concept of this question. Now you see what's how we'll proceed in this question. A die is rolled. Okay, let E be the event, die shows 4. First you write down the say die is rolled. So what is the sample space of the die rolled? Sample space will be 1, 2, 3, 4, 5, 6. This is the sample space. And E is the event. Here say event. Event it says die shows 4. So this event is what? What is the sample of this event? Die shows 4 means there is only one element. And F is what the event is F. F is another event. We say die shows even number. Means we have even numbers. You say 1, 2, 3, 4, 5, 6. 2 is a even number. 4 and 6. So we have these three elements are even. Now look out here. E and F. The intersection of E intersection F will comes out here 4. So it is not the null set. That's why events are not mutually exclusive. Mutually exclusive. We see not mutually exclusive. So events are not mutually exclusive because their intersection is not equal to 5. Now we want to do the question number 4. Say the question says what? 3 coins are tossed once. Letter A denotes the event. 3 head shows. B denote the event. 2 head and 1 tail shows. C denote the event. 3 tails shows. And D denote the event. A head show on the first coin. Which events are? We see here the mutually exclusive, simple, and compound. Say for mutually exclusive, I say that events are, we say the two events are mutually exclusive if A intersection B equal to 5. Event is a simple event. If it contains only one element, I say the single element is there, then we say a simple event. Event is a compound event if it contains more than one element. I say A, B, and we say so on. If it contains more than one element, then we say the event is a compound event. So these are the basic theory to for that. A coin is tossed three times. So means you have a one coin. It has a points head or tail, and we are doing this sample space. So let's see how can we proceed in this question. So first of all, you write down the sample space. What is the sample space is there? Write down the sample space. Sample space of the event. Three coins are tossed. This is the experiment, and we will get either head or tail. So we say that yeah, we are getting the three head. Okay. We are getting the two head. We are getting the one head. We are getting the no head. No head means we are getting all tail. This is the sample space. And you see in this sample space, the number of elements are, you can see 1, 2, 3, 4, 5, 6, 7, 8. There are the 8 elements in the sample space. Now, A is what the event A says. Event A says 3 had, so 3 had, so this is the event. The 3 had source, this is the event. So 3 had source, how many elements are there in this 3 heads? Only one element is here in this event. Now see what is the B event. 2 head and 1 tail. So we see 2 head and 1 tail. So this is a B event. Is that B event? 2 heads and 1 tail. Tail. So will be equal to, you can say 2 heads are there. You say H H T H T H or T H H. We have this. C is the event. C denotes the event. 3 tail source. 3 tails. So 3 tail source, only single element T. T T T. D is another event. A head source on the first coin. A head source on the first coin. This will be the event what? First head, we say all H. We say HHT. We have HTH. We see. Then we have HTT. This 4 is the. Now, we want to find out which events are mutually exclusive. Okay. Events are mutually exclusive. Events are there or not. Sample space has no meaning. We need only the events, 4 events, A, B, C, D. So we just find out the intersection. A intersection B. Is anything common? H, H, H. Here is no H, H, H. So you see here A, and this is B. Nothing is common. So we say it is a 5. Okay. A intersection C. See H, 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 H. And here is, you can say H, H, H. And here is T, T, T. Nothing is common. No element is common. So again, you can say it is a 5. Next, A intersection D. D, not C, it is a D. A intersection D. You see this one, A intersection D, we say here H, H, H is there, and D, H, H, H is there. This one element is common only. So it is common element is H, H, H. So it is not equal to 5. And now we say B intersection C. B intersection C will comes out You see this one. This is a B events are there, HHT, HTH, and TTT. So nothing is common in B and C. So B and C, there's nothing is common, no element is common. So we say it is a also 5. B intersection D. Not, I'm writing C. B intersection D equal to what? You see in the B, HHT, HTH, THH, and here also you see HHH, HHT. HHT is common. HTH is also common. These two elements are common. So we have two elements common in B intersection D. Write down these two elements, HHT and HTH. So this is not equal to 5. The another one we can say C intersection D. C intersection D. In C intersection D, I say this and C, we have only TTT element, and here no TT elements are there. Nothing is common. It's also 5. So say A intersection B equal to 5. So A and B are mutually exclusive. This pair set A and B are mutually exclusive. AB pair is AC pair is also mutually exclusive because it is 5. B and C is also pair mutually exclusive, B and C set. And we have C and D. C and D are also mutually exclusive. So we have 4 pairs are there. They are mutually exclusive. Now, in the question, now we want to find out simple. Which events are simple? We are interested to find out which events are simple. Simple events means they have only single element. You see, we have 4 events A, B, C, D. So event A, we have a single element only. So single element is there here. So event A is a simple event. You say B is not a simple event because we have a more than one element. C is also single element is there. So we say that it is a simple event. Or you say D has more than one element. So D is not the simple event. So we have only 2 events, A and C. Those are simple events. So you can say simple events are A and C. We write down here simple event A and C. A and C are simple events. Now, other questions they are asking you that this is a compound event. Compound event means we are looking the events that has more than one element. Now, you see, A has only one element, so it is not a compound element. B has more than one element, so B is a compound event. C has one element, so C is not a compound event. D has more than one element. In fact, 4 elements are there. So we say D is a compound event. So we have a compound events B and D. So we have compound event B and D. So this is the end of this question number 4. Now, we want to discuss the question number 7. Okay. Question number 7 says, refer to question 6 above, state true or false. Give reason for your answer. Number 1, A and B are mutually exclusive. A and B are mutually exclusive and adjustive, and A equal to B dash. See, in these questions, what we are want to say in this question is that first, Event A and B are mutually exclusive means A intersection B must be equal to 5. Then they are mutually exclusive. Second, A and B are mutually exclusive and adjustive. A and B are, first we talk about what is the meaning of the adjustive. A and B are adjustive. A and B are adjustive. Adjustive. If A union B equal to sample space S. So we say that here this is a sample space S. We say if it satisfies both these conditions, then we say the A and B are mutually exclusive and adjustive. A equal to B dash. What is the meaning of this part? A equal to B dash. Means what? B dash is that here. B dash is means what? This is a sample space minus B. So this is a meaning basically. That's what we have to find out in this question. So we want to refer the question number 6 for the data A and B. All right. We are interested only the data in data A and B. And then we want to do the question. Two dice are thrown. The events A, B, and C are as follows. A, getting an even number on the first die. So see, what is the sample space? Two dice are thrown. So element in the sample space is 36 elements are there. The first die we are getting the 1 and second die we are getting the 1. First die we are getting the 1 and second die we are getting the 2. First die we are getting the 1, second die we are getting the 3 and so on. 1, 4, 1, 5 or you can say 1, 6. Okay, fine. Then we say that here right on the next row. We say that we are getting the 2, 1, 2, 2, 2, 3. First die we are getting 2, second die we are getting the 4, 2, 5, 2, 6, and then we are getting 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Now we say 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. See, we know the questions that A and B are mutually exclusive or adjustive or B dash. So all right. We have to write on the element basically, not the values. This one. Now, next values are this is 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, comma. Now, the another elements is 6. The first die we are getting the 6 and second die 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So this is a sample space. Now, what is the event A? Event A is what? You see, getting an even number on the first die. Getting an even number on the first die means we are getting the 2 number on the first die. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. All right. And we have even number in the first die. 4 will be also even number. 4, 1, 4 comma 2, 4 comma 3, 4 comma 4, 4 comma 5, 4 comma 6, and then we have 6 series 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, and 6 comma 5, and 6 comma 6. You see the number of element in this set event A is we have 18. In sample space we have element 36 are there. Now B, getting an odd number on the first die. B means on B we are getting the odd number on the first die. This is the B event. So A, B events are there. Odd number on the first die 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6, comma 3 comma 1, 3 comma 2, 3 comma 3, 3 comma 4, 3 comma 5, 3 comma 6. Okay. Next 5 comma 1, 5 comma 2, 5 comma 3, 5 comma 4, 5 comma 5, and 5 comma 6. So again the B elements event you can say we have it 2. Now we want to check whether they are mutually exclusive or not. A intersection B. You find out here. Is any element is common? 2 1 is here. Is any 2 1 is here? No. 2 2 is here? No. 2 3 is here? No. Any element that is coming with a 2 is not available in set B. Okay. In a pair that start with a 4, 4 1, 4 2, 4 3, there's no 4 1 is here. No 4 2 is here. You see. I'll say 6 1. No 6 1 is here. 6 2 series is any number that start with the 6 pairing. It's not here. So no element is common between A and B. So we say A and B intersection is 5. So A and B are mutually exclusive event. This is the one answer, that A and B are mutually exclusive event because no element is common. Second, we say the union. Take the union. If we take the union of A union B, we are finding this 18 element and this 18 element, we are getting all these 36 elements are there. You see that here it started from the 1 1 to we say 1 6, 2 1 to we say 2 6, 3 1 to we say 3 6, 4 1 we say up to 4 6, 5 1 we say up to the order 5 6, and 6 1 up to order 6 6. So we have a 36 elements, and that is equal to what? You see this one, and come back here. You see what is the sample space. These are sample space. 1 1 to 1 sets, 2 1 to 2 sets, 3 1 to 3 sets, 4 1 to up to 4 sets, 5 1 up to 5 sets, 6 1 up to 6 sets. 36 elements are in the sample space. And now A union B also has 36 element. 1 1 up to 1 sets, 2 1 up to 2 sets, 3 1 up to 3 sets, 4 1 up to 4 sets, 5 1 up to 5 sets, 6 1 up to 6 sets. So we have a 36 element. So it is equal to what? Sample space S. So A union B equal to sample space S implies that A and B are adjustive exhaustive event. So we see that here that A and B are mutually exclusive as well as exhaustive events. Now the third part, you see this A and B. What is the relationship between the A? A equal to, you can say, A. You see this A and B are mutually exclusives are there basically. So you see the set of A equal to what? B dash. B dash is nothing. This is a S minus B. So this is the end of this questions. Let's say also you can say what is the B dash. A equal to this one. And what is the B dash? B dash will say how we write on the B dash first. Write on the B dash. B dash comes out the element that is in the sample space but not in B. So we will say getting the values. We are here 1 1 up to 1 6, 3 1 up to 3 6, and 5 1 up to 5 6. So this is nothing. This is nothing. This is equal to A. So we say B dash equal to A. So this is the end of this chapter.